Welcome to the tutorial. In this video, I'm going to be showing you all how to make an isometric platformer in GDevelop. Now, before you watch this video, if you are a complete beginner, you should not be watching this video. You should be watching the No Code Revolution, which is a free course I have down in the description. You can join it for completely free. But if you are ready for this tutorial, let's jump right into it. Now, the isometric platformer is not as complicated as you think, especially when we're doing a flat platformer. And a flat platformer in this case is where isometric. We're not going to be going really low, like we're going to be going from one platform like this to another platform on the side. This is flat platforming. Now, if you all want part 2, make sure to get this video to at least 1K views, and I'll make a part 2 with better platforming. Now, this is a simple isometric platformer. Now, the first thing we need to do is actually set up the scene. Now, here I have a player object, and I'll have this asset down in the description, but you don't need to use this asset. You can use any player you want. It's not animated. It's not animated because we're just simply focused on the platforming, but we're not going to animate the object here. But also we have these blocks. And the way that I got these blocks, these are free. So I went to the home and then I went to the shop. It'll look like this when you first get into the shop. And then all you have to do is type in isometric. And let me wait for the type in isometric and then hit enter. And you should see the Kenny isometric blocks pop up. And then all you have to do is add them to the project and make sure you click untitled scene. When I use global objects, that didn't work very well. And once again, they don't need to be global objects. So just add it to whichever scene you want to add it to. And once you do that, then you have a block set up. Now let's start with these blocks. Now when it comes to setting up isometric blocks, you can see, like, let's say we want to make some landscape. We want to make some landscape or want to make a big platform. If we try to just line it up here, you'll see that it's not going to be 100% accurate. And it's not going to be consistent if we're trying to line up a bunch of these blocks. So because of that, since it's not going to be consistent, we need to use GDevelop's grid system. And going to the grid, we can go up in the top right corner and you'll see toggle/edit grid. Then you click that and you put set up the grid. Now this is very simple to set up the grid. We're setting up the grid based on our blocks here. Now I already have a preset, but I'm going to explain later how I got to this preset based on the block size. Now, based on our block size, I'm going to set this cell width to be equal to 55, and we're going to set the cell height as equal to 31. Now, this is the most important part. Make sure you click isometric. If you click isometric, GDevelop will set up your grid in a way that's specifically for isometric blocks. So now that we have this, we're going to hit apply, and you see that we still can't see the grid. We need to go back up to toggle/edit grid, and then put show grid, and now we'll have the isometric grid set up. Now, the way that I set this up, to make sure the grid was correct, is that I took two blocks and I put them side by side. I put 2 blocks and I put them side by side like this. And then I subtracted. Well, you put them side by side like this, and it may take a little bit to align it right. So now we have it aligned right. Now basically what I did is I took the second block right here and I subtracted 302, which is X position, and I subtracted it from 248. And then I did the same thing for the Y. I subtracted 419 from 388. And using those numbers, I set up the grid. So this is completely dependent on your block size. If you're making smaller blocks, you're going to have to alter this. If you're making bigger blocks, you're also going to have to change this value. So that's how the grid system works. That's how it's set up. And now we have it correctly set up. Now, if I preview, let's see how this looks. If we have these 2 blocks side by side. You see these 2 blocks side by side, they look pretty cool. And let's see if I alter the Z. Let's say I set this Z as being really high, and I set this one as lower. I've set it to 1. Let's see how it looks. If I preview it, you see that start to look really weird. And that's because GDevelop, the Z position or the Z order, that's what it's called when it's 2D, the Z order decides which objects will appear over other objects. Now, as a rule of thumb, for isometric, when the object is down lower like this, you want to set this block Z order as being higher. So we're going to set this Z order back to 1, and we're going to set this Z order as 2. Now, you may think this is pretty tedious for designing maps. I don't want to have to do this the whole time. Now, there's a way that you can easily do it without doing all this tedious Z order stuff. And you can go into the Extensions tab by clicking the Project Manager in the top left, and then we go into the Extensions tab. Now, you can type in Y-sort. This is what it's called, Y-sort. And you'll see that if we click into it, it says create an illusion of depth by setting the Z order based on the Y position of the object. And this is useful for isometric games and 2D games with a top-down view. And we're using we're using this for an isometric game, so this is perfect for us. So we're going to install this into the project. And now we won't have to do all the weird things with the Z order. The blocks will automatically look right no matter what we do. They'll automatically look right when we run the game. So now that we have that, I'm going to quickly set up a little bit of some ground. And we're just going to set up some ground. It doesn't have to be perfectly aligned, especially since we're just testing things out. And another thing, when you're designing your map, you'll see that you'll run into situations like this. And even though if I preview this, let's see how it looks inside the editor. If I preview this, you'll see that it looks very weird. And we have to, that's why we have to set the Z order to be different, depending on just how things are. So if I set the Z order here to be equal to something lower, like 1, and I set this Z order as being equal to, well, let's set this one equal to 2. Let's set this Z order as equal to 1 or 3. It just really depends. We have to do things in a certain way. Yeah, let's set equal to 1. So you'll see that this is the pattern. The one on the side has to be lower, a lower Z order, and the one on this side has to be a higher Z order. So that's how we have to do the block system. And from there, we can just keep duplicating, and then we can actually design the maps so they'll actually look right. And we have this small chunk of land. And if you want to make this a little bit faster, since we want to make a bigger platform, we're going to copy and paste it. Then we're going to duplicate it. And now we have it set up. We have a much bigger platformer. Well, platform, misspeaking. So now we have our platform. Now let's make our player. Let's make our player object. So if I drag the player onto the scene, you see that's really, really, really small. So we're going to make it bigger. I'm going to drag this width and move my mouse to the right to make it bigger. And I feel like this is a good size right here. This is pretty good. So now that we have this player size, if I preview, you'll see that we can't do anything at all. Our player's on top of the ground, which is cool, but we still can't do anything. So how do we make it so our player can actually move? Well, this is simple. We're going to use GDevelop's top-down behavior extension. Well, not extension, but it's just simply a behavior. So let's double-click into our player. We double-click into the player, and then we go into behaviors. We add a behavior, and let's scroll down, and you'll see that we have top-down movement. Now, for this, we're going to allow diagonals. We're going to keep the default controls. We don't want to rotate the object for when we move around, but we also want to go into advanced properties. Now, when we go into advanced properties, you'll see that we'll have something called the viewpoint, and the viewpoint is extremely important. You'll see we have 3 main viewpoints. Well, yeah, 3, actually 4 in this case, 4 main viewpoints. We have top-down, we have isometry, true isometry, and custom isometry. And this is based on the blocks of your game. Now, we're using the basic type of isometry. Now, I'm not an isometric expert when it comes to the angles and the mathematics behind it, but I know from testing that our blocks that we're using, isometry to the ratio with 2:1, this is the common one that's used for the most sprites. This is the common isometry. Now, this will all depend on your game, and if your movement is not right, you want to play around with different isometries depending on your block size. Now you'll see that if I go down and right, let's say I put down and right on my keyboard, and that's what I'm pressing right now. If I put down and right, you'll see that I'm actually moving directly straight across the platform. Moving straight. And if you don't like this, you can see it's not 100% straight. You can just use a custom isometry until you get the perfect feel that you want. Now, another thing I'm going to do is double click to our player, and then we're going to go back into our settings, and we're going to set the acceleration as being a really high value, and also set the deceleration as being a really high value. That way we'll snap. Our movement will be snappy and instant. We'll instantly stop and we'll instantly move. So now if I preview this one more time, you'll see that I can now move. It's just instant. Now, like I said, this is not 100% perfect. You might want to play around with the isometry, because for these blocks, it's always going to be different depending on your blocks. But for now, this basically does the trick. It doesn't have to be 100% perfect. Now, for the main part is making the jump. Now, you may be wondering, how are we going to do the jump? Because this is a 2D game. As you can see, I'm not in a 3D project. This is a 2D game, which means we're already moving the Y direction by going up, and we're already moving the X direction or axis by going left and right. So how are we going to do the jump? The way that we're going to do the jump is we're going to be changing the camera zoom. Now, the camera zoom is an effect that makes it look like we're jumping. That's commonly used for isometric games. Basically, we zoom up the sprite to the camera to make it have an illusion that we're jumping. And there's other ways to give an illusion that you're jumping, such as using a shadow. But for the sake of this tutorial, we're just going to simply do the zoom feature so that we can tell that we're jumping. So if I go into my untitled scene events, and let's go into adding an event. Now the first thing we can do is assign a button that we want to be our jump button. And we're going to make that the space button in our case. So let's add a condition, and we're going to go into other conditions, scroll down and go into the keyboard, and then put key press. Now if you press your key, we want the space key is the one that is going to be pressed. Now, how are we going to actually do this camera zooming in? Well, we have to make it smooth. And basically what we're going to do, we're going to have an object that's called the tweener. And our camera zoom will always be set to the X position of that object. And we're going to be tweening the X position of that object so that our camera zooms smoothly. Now, if you don't know what I'm talking about, let's do it right now. So let's go back into our scene, and let's create a new object. I'm going to add an object, going to make this a sprite, and it doesn't matter what it's called, but we're going to call it tweener. And I'm going to import an image, and let's just use this red cube right here. It does not matter what your image is, and let's add a behavior to it. Now, the behavior that we're going to be adding is called the tween behavior, and this is simply used to smoothly change values. That's basically the way that tween is used. We can smoothly change values. Now, by default, our camera zoom is supposed to be at 1. And remember, our camera zoom is always going to be equal to this X position of tweener. So that means we're going to set this X as being equal to 1 always. And we're also going to put it out of view. So we're going to set it to equal to -64. It doesn't matter what value, just make it out of the camera view so the player doesn't see it. So now that we have that, we need to also make a condition in a new event. And this is going to be completely blank because we don't want there to be a condition that sets the camera zoom. This is going to be something that always happens. Now, let's add an action. And we want to change the camera zoom to always be equal to the X position of the tweener. So we're going to go down, and we're going to go into camera. I went down a little bit too far. Layers and camera, and you'll see down here we have the camera zoom. And now we can set the camera zoom, instead of being equal to something like 1, we want to access the X position of our tweener object. So to access the X position of any object, you first type the object name. We can type tweener, and you can press tab to autocomplete it. Then we put .x, and then we put the parentheses. This is the way that you access the X position. And we're on the base layer, so it doesn't matter. And we're also going to set the camera number to be 0 by default because we only have 1 camera. Now let's click OK. We have that. So now we're changing the camera zoom to always be equal to tweener. Now another thing we need to do is actually make the jumping. We need to make the jumping. And basically what we're going to do, we're going to tween the X position of the tweener to go a little bit higher to make it look like we're jumping because we're zooming up to the player. And then we're going to make it go right back down. So how do we do this? Let's make an action. Add an action. And we're going to go into the tweener. Let's type the tweener because we have a bunch of block objects. So to find it, let's type tweener. And then we'll get it. We'll get it. So now that we have that, we want to go into where it says tween. We're going to type tween position. And we want to tween the X position of the object. Now the tween identifier, we're going to call this up. And this is basically the name of the tween. You want to make sure these are different names if you're doing a different type of movement. So we're going to call this up. And we want to tween it to 1.3. And the reason why we're doing this is because if we make a high number, our player is going to be super zoomed up. And if our player is really zoomed up, it's just going to look really bad. It's not going to look like we're jumping. It's just going to look like we turn giant. So we're going to keep it linear. Linear is just a basic tween. These other tweens, they could work, and you can test them out. But linear is just a good thing for most games. And the duration, this is going to be how long will it take us to reach that value of 1.3? How long will it take us to go from 1 to 1.3? And for the duration, I'm going to set this as 0.5. Depending on how high your jump is, you may want to make the duration shorter or make it longer. And we don't want to destroy the object when this tween finishes. So we're going to hit OK. And now that we have that, at a certain point, we want our object to go back down. We want our object to go back down. So we're going to wait a certain amount of time, and then we're going to make our object go right back down. So we can easily wait a certain amount of seconds by going to other actions. Then we go into timers and time. And then we wait X seconds. And we want to wait 0.5 seconds, which is just half a second, before we start going back down. Once again, if you have a high jump, you want to make this value much longer. And finally, we're going to tween the X position back to 1, which is what it originally was. So we're going to add a new action. We're going to type in the tween object once again, tweener. And we're going to go down. And I'm going to go down. Let's just type it in. Tween object X position. Found it. And we're going to name this down. We're going to name this down. And we're going to tween to the X position of 1. And this is going to take 1 second. And basically, it'll take us 1 second to go back to the ground. So basically, it takes us 0.5 seconds to go to our peak height. And then it takes us 1 second to go back down to ground level. So now that we have that, let's preview and see what happens. So if I press space, you see that it's zoomed in a lot. And not only, it's not just zooming into the player, it's zooming into the entire scene. And that's not a good thing. But we only want to zoom into the player, because that's how we get that effect going. So let's add a new layer. Add a new layer, and let's call that layer player. Let's call that layer player. And we're going to get rid of this effect. I don't know why GDevelop does this. It automatically adds a 3D light effect to any layer that you make. So let's go ahead and delete that. But now we have our player layer, and we're going to click into our player, and we're going to put player on that player layer. So let's go back into our untitled scene events, and you see that we have here the change the camera zoom. Now we're going to put the layer on the player instead of the base layer. So let's hit OK, and let's preview. So if I press space now, you see that actually kind of looks like we jump now. Once again, you can make this effect better by adding a shadow. You can make this effect much better by adding a shadow and adding an animation that signifies that the player is jumping. For now, we have this little jump right here. And this is a very slow jump. Now, we do have an issue. We can stall ourselves in the air. Like, if I keep pressing space, I can stay stuck in the air. And that's why we need to have a detection system where the game knows, okay, our player is on the ground. Now, you may be wondering, this is not just a regular platform controller. So how do we detect whether or not our player is on the ground? Well, we can use a little bit of logical reasoning. Think about this. Normally, when we're on the ground, this tween value is equal to 1. That signifies that we're on the ground. Therefore, our condition needs to be if the space key is pressed and if the tween object is 1. If the X position of the tween object is 1, then we can jump. If our tween X position is not 1, then we can't jump. This stops us from being able to jump in the air. So let's add those conditions. We're going to add an AND condition. So we go into other conditions, events and control flow, and then we add AND. And then we go into our sub condition, and let's make it so the tween object, it has to be having an X position of 1. So we're going to type in X position, and we want to make sure that it's equal to 1. And I'm going to put trigger once because I don't like hold to jump. Remember, every time you're doing a jump, if you want to make it hold to jump, you won't add a trigger once. But if you don't want the player to be able to just hold space and keep jumping, then you put trigger once. So I'm going to go into other conditions, events control flow, trigger once. And I'm going to hit preview now, and let's see what happens. If I press space, I jump. And I guess it works a little bit different. I'll have to move it up. Let's press it. Now, let's see what happens. If I hold space, if I jump, it won't keep jumping. I'll have to press it all over again. So that is how you program that type of jump. Now, we don't actually know if this jump is working, and let me just tell you right now, not even be suspenseful. The jump is not working. If I made a dangerous object that we had to jump over, if we tried to jump over it, we would still die. We would still basically die. So how are we going to do this so we can actually jump over dangerous objects? Now, the first thing we need to do is actually have a dangerous object. Now, if you see here my setup, I already have a dangerous object, which is just a red version of the same object. Yep, super scary, super dangerous. But I'm going to add this in the middle of the ground. So I'm going to remove these 2 blocks and replace it with these red dangerous objects. And let's set the Z position as being the same as these other blocks so it can fit in. It might have to be lower. Never mind, the same. We're going to set it to be the same. And we may have to alter the Z positions whenever we're making new parts of the map. That's just kind of how it is. That's the most annoying part about trying to make objects for isometric. So we're going to change these Z's accordingly. Once again, this Z is always going to be lower over here. So we're going to change this to 11. And now the block is actually fitting in better. And now these Z positions need to be changed as well. So we're going to set this as being equal to 14. This one right here. I'll set this being equal to 14. And we're going to set this one as being equal to 13. So I'm going to click this block and equal to 13. Then we drag it into place. Now you can kind of get the pattern right now. You can kind of get the pattern. Whenever you have a block like this, and then the block to the side always has a higher Z order. And as you go down in this column, your Z order should be getting higher. Your Z order should be getting higher. So now we have it set up and we have a dangerous block. Now the first thing we want to do is make it so when we touch that block, we want the player to immediately just die. So the player gets destroyed when it touches that block. So let's make it so if the player is in collision with danger, then we'll delete the player object. So let's add a condition. If player, we're going to click him, and then type in collision. If player is in collision with the danger object, then we hit OK. If player is in collision with danger object, then we want to delete the player. We want to delete the player. So I'm going to click the player, then type in delete, and hit OK. And now when we walk over this object, we should be destroyed. And don't worry about how you can go off. We can change this easily later, but that's not what this tutorial is for. So we're going to go over here, and now when we touch the object, we die. Now, a common thing that we should do is to make platforming easier. We should edit our collision mask on the danger object, and then you can use a custom collision mask. You can set it as something much, much smaller. You should set this collision mask as something much, much smaller. And I forgot to do this earlier, but let's edit our collision mask for our ground object as well. And we can edit the collision mask so it actually matches more. So we can use a custom collision mask. Once again, set this as something more accurate. And let's change it right here. Definitely not 100% accurate, but it's good enough for right now. I'm going to go back into the danger object, and I'm going to make it even smaller. Because, like I said, we want the player to have a little bit of leeway when it comes to platforming. So we're going to set this hitbox as being really, really generous. Especially if you're making an isometric spike or something like that. So this is a very, very, very generous hitbox. Now I preview. Let's see if we try to jump over the danger object. What is going to happen? What is going to happen if we try to jump over the danger object? Well, if we try to jump over it, we still die. And that's because, remember, the game doesn't care about us doing our little fake jump. We have to tell the player whether or not we're fake jumping. Because remember, there's only two axes, the x-axis and the y-axis when it comes to 2D. So now we have to make a detection system for our fake little jump. So now, in order for us to detect our fake jump, we have to make sure we're basically going to be doing the same thing that we did earlier. If the player is in collision with danger, and if the player is on the ground, which means if our x position of the tweener object is equal to 1, then we want to delete the player. So basically what we're saying is if player is in collision with danger, and if the player is on the ground, then we'll delete the player. So that's the condition. So actually I can just click this and right here and copy it and then paste it, and we'll have that exact same what's the word for it? The exact same condition for it. So let's preview now and see if we can jump over the object. Let's preview, and if I jump, let's time it right. We go ahead and we jump over it, and we can move to the other side. So you can jump right back. Now what happens when we try to walk over it? We'll still die and get deleted. Now that is that simple. It was much simpler than we expected. The most complicated thing as a recap, what we did first is we made our ground objects. And the way that the pattern goes is that your block right here, you start with a block at the top right, and this one has a low Z order. Then the one next to it has a higher Z order. And as you go down, this one should have a higher Z order. This one should have a higher Z order. But the one to the left of it, well, the one to the right of it, should always have a lower Z order, if you get what I mean. That's the pattern of it. And once again, we use our extension YSort. Make sure that you set your player's behavior as having isometry or true isometry. You can try these different ones. I didn't want to go over all of them because it might take some extra time, and I'm also not a mathematical expert when it comes to isometric games. But that is how you simply create a jump. Once again, if you would like a part 2 for this tutorial where we cover going down. Let's say we had a block all the way down here. Let's say we have a block all the way down here and we want to jump on it. How will you do something like that? Those are things that we also want to know how to do using our isometric. And I believe it still works the same. It may not even be anything complicated. I just might be overthinking things, but I just get a bunch of weird scenarios in my head. But anyway, that is the end of the isometric tutorial. If you enjoyed the video, make sure to like, subscribe, comment down below what tutorials you want to see next, and also hit the notification bell so you never miss out on any of my new tutorials. Also, make sure to join the Q crew in the description using the link, and you'll get a free course, the No Code Revolution, as well as you'll be added to the email list. And we have the No Code Revolution Season 2 coming up, which is teaching you how to make a complete platformer game that features combat. The course gets updated. There's so much that's coming up in the new No Code Revolution. So make sure to join the QQ for that free course and just to become a part of the Q, the game dev community. Once again, if you enjoyed the tutorial, make sure to like, comment, and especially subscribe to Q, the game dev. We're almost at 2,000 subscribers. Once again, I hope you all enjoyed the tutorial, and I'll catch you in the next one. See ya.